right, so for your notes for P.6, it's just a review of complex numbers, imaginary numbers, and we looked at this again in your summer packet there. So remember, imaginary numbers, if you look at what the graph is going to look like, if you have a quadratic equation like this, y equals x squared plus 1, if you graph that, here's your graph over here, the graph never touches the x-axis, so it doesn't have any real numbers that are solutions. It doesn't have any roots or x-intercepts, but it has imaginary solutions there. And the imaginary values then come from this idea here. If you have the square root of a -1, that equals I. It's a new notation. And then if you squared both sides of this, you would just get the number that's underneath the radical there, which is -1. So these two values, I squared equals -1 and I is the square root of -1, really those are the only two values that you need to remember. So imaginary numbers is just a number that has that I in it. Complex numbers are a combination of real numbers and imaginary numbers. So A plus BI. A is the real part, the BI is the imaginary part. And if it's written with the real part first, the imaginary second, that's in this standard form here. Let's see what else we have here. Let's skip down to the examples because I think you remember most of this from the summer packet there. So adding and subtracting imaginary numbers, you add the real parts together. So 7 plus the 4 will give you 11. And then the imaginary part, -3i plus 5i, is going to give me plus 2i. And then for this second example here at the top of the next page there, the same thing with subtraction. So 2 minus 8 will be -6. -i minus a 3i would be a -4i. So adding and subtracting, just like you would do if those were not i's, if they were just any old variable, an x or a y. Multiplication is just a little bit different because you may end up with an I squared in the problem. And if you end up with an I squared, we can convert that and make that a -1. So the first example here, we just FOIL this. So first times first is going to give me 10. Outer is going to give me -2i. The inner will be plus 15i. And then last times last would be -3i squared. And then if I can combine my like terms here, I have 10. I have plus 13i. And then here's this I squared. This is -3 times an I squared, which is equal to -1. So -3i squared is really plus 3. And now I can combine those two real parts together, 13 plus 13i. All right, and then the next example is the same idea there. The only thing that's different is now that's written with an exponent there. So if you want, you can write this out twice. And then you're FOIL it again. First times first will give you 1. Outer is -2i, inner is -2i, which is -4i. And then last times last will be plus 4i squared. 4i squared is equal to -4. So I'd have -3 minus 4i. So working with complex numbers, and really they're the only two types of things I think that you will see with complex numbers there. And then we've talked about this, the quadratic formula there, the number that's underneath the radical is called the discriminant, right? And if that discriminant value is a negative, that means you're going to take the square root of a negative number, which means you would have imaginary roots. Or you could say complex roots. Complex numbers. So we went through this before. If it's discriminant was positive, you have two real solutions there. Distinct means they're different. B squared minus 4ac. If it's equal to 0, that we were calling the double root. You get the same number twice. And then this is what we just talked about, the imaginary roots. Remember, conjugate just means if you had 2 plus 3i as a root, that means 2 minus 3i would also be a root. They're conjugate pairs there. All right, so let's look at this last example then here. If we go through and solve this algebraically, figure out what kind of roots we're going to have, and then you can put the same calculator if you like. X squared plus x plus 1. It says describe the roots. So the types of roots that we're going to end up having, we would have quadratic formula, just the discriminant part. B squared minus 4ac, so 1 squared minus 4 times 1 times 1 would be 1 minus 4, which is negative 3. That would be the number that's underneath the square root in the quadratic formula there. So we would have 2 complex conjugates for roots. Or before we were saying just 2 imaginary, and that's fine. Right. This is a little more descriptive, describes it a little bit more. And then it says, let's go through, let's find the actual solution set. So we can go through that. So x equals negative b, so negative 1, plus or minus the square root of b squared minus 4ac, which you just found was negative 3, divided by 2 times a, which is 1. Square root of negative 3 is going to be I root 3, divided by 2. Nothing reduces here. So we did indeed have 2 complex conjugates, 1 plus I root 3 over 2, negative 1 minus I root 3 over 2. Okay, so you have homework problems that are in the book. This worksheet that comes afterwards, this little maze here, you can actually go through, you're going to do this little maze right now, and then you're going to have the problems from the textbook that's on the assignment sheet and probably on the front board here for you for homework.